Hi folks, welcome to Science Sunday with Josh. This week we are going to be doing a probability exercise involving some tools from around the house. In this case, I'm using dice from a board game I own. You can use any six-sided dice. 2 is the number that we want. Or you can use coins, and the instructions for using coins will be in the PDF linked below, as well as results tables and a little bit of a more thorough instruction in case video doesn't work very well for you. Because I know sometimes when I'm watching a video, doing the two things at once is difficult. So, if you'll bear with me while I move the camera, I'll show you what we're going to do. So, before we start making randomization, what we're going to do is create a result table. You'll note that this one is already filled out a bit because I'd already been doing this. But what we want is, what are the possible results on the dice? Well, for two dice, that is to say, two six-sided dice, where we sum a total, we can have between 2 and 12. Like when you're playing Monopoly, you roll the two dice to see how far you go, you add those numbers. We're looking at the same number total. And so what I did then was I took my dice, once I had my table set up, and I rolled them. Look at that. A 2 and a 1, I get a 3. Then, take my marker, boop, add a tally mark to 3. Now, I did this a total of 20 times, and then I made a bar graph. And a link for a video on how to make a bar graph is in the PDF that comes attached to this. And so here's my bar graph. I put the count, how many times things occurred over here, and my results along the bottom. And then, for every time it occurred, 3 blocks on my graph paper then represent one time of the incident occurring. It's just so it made it easy for me to see what was going on. And so once I had this graph, I can notice a pattern that has occurred. I am most likely to roll a 6, a 7, or an 8. Those are the things that happen most often. And I almost never get a 2 or a 12. And I know from probability that I study in college that in actuality a 2 and a 12 are really unlikely to occur, whereas a 7 is the most likely to occur. So this kind of confirms that information. And confirming information is a big part of science. Hold on while I move the camera again. So why are graphs and data important? Well, what they allow us to do is to put information in a way that's readily digestible by others. That is to say, it makes it easy to understand. So on my graph, I found that 6, 7, and 8 are most likely to occur. I verified some other information that I already knew about what probability it is. And this allows me to take this information and go to somebody and say, hey, look, I tested this. This is what happened. And that's a big part of science, is testing things that we kind of know the answer to, but want to make sure about. And that's how the scientific method works. You have a question, you check other data, and then you try it yourself. That sort of review of information, that redoing, is how we create theories and laws in science. And those will become more readily important the longer you study science. And outside of science, data gathering like this is also important because it allows us to understand trends and patterns. And trends and patterns are really important regardless of what discipline you go into or what you do with your life. Whether you are running a restaurant or working at a restaurant and you need to know how much to buy of something, what to order, what sells, what doesn't. The same working at a library. We have to know, well, what books see circulation, what don't. And we use data and graphs like this to convey that information to each other in a way that is readily understandable. And so, the point of this exercise? Just to understand how gathering data works and how to transfer that data, that raw stuff you have, into something that's easy to see the patterns in. Thank you again for another Science Sunday with Josh. Have a good one.